Hello, everyone, and welcome to Today in Space. On this segment, this is people of science. So we're going to talk about people that have worked in science or were currently working in science. I want to bring the diversity to the people that experience science, have it be a part of their life. We have the pleasure today to have Ozan Varol on the show here. He is the author of the new book, Think Like a Rocket Scientist. Ozan, thank you very much for being on.
It's my pleasure to be here, Alex. Thank you so much for inviting me.
Of course. First, before we get started with anything, I would love for you to give a quick origin story of who you are, where you came from, and kind of tie that off with what got you into science.
Sure. I was born and raised in Istanbul, Turkey, and lived there for 17 years before moving to the United States for college. But the reason why I got interested in science initially was, it's an interesting story. I grew up in humble circumstances, and our electricity supply growing up was fairly unreliable, which made blackouts a common occurrence, and a frighteningly common occurrence, I should say, for a little boy. And so my dad came up with this game where, we'd light candles around the house, and he'd take my soccer ball, and then he'd rotate the soccer ball around the candle representing the sun, and the soccer ball the earth. And that was my first astronomy lesson, and I was hooked. I remember growing up, reading Carl Sagan's Cosmos, watching Carl Sagan on TV, and I was really into science fiction as well. And so I started dreaming about moving to the United States one day, majoring in astrophysics, and then working for NASA. And that dream came true when I got into Cornell to study astrophysics, and I left Turkey at 17. And about maybe a week or two before I left, I was researching what the astronomy department at Cornell was up to, and I saw that a professor, Steve Squyres, was the principal investigator of this Mars mission. And at that time, it was going to be two separate missions to Mars, one in 2001 and one in 2003. And I was so excited. He had worked under Carl Sagan as his graduate student, which was doubly exciting for me. Mm-hmm. So I reached out to him and asked him if he was hiring anyone to work with him. And he asked me to send him my resume, and the rest is history. I ended up getting a job, I think the first or second week that I was at Cornell, and working with him on the operations team for what ended up being the 2003 Mars Exploration Rover's mission.
We'll talk about a launch of, first of all, going to the United States and then just jumping right in. I mean, it's almost like you spent no time. It's amazing.
Yeah, it was surreal in so many different respects. One day I was sitting at home in Istanbul, sort of daydreaming about space, and then 2 weeks later, I had front seats to the action.
That's crazy. So you were able to work on the Mars Exploration Rover mission. So tell me more about what did you do? What were you involved in there?
Sure. So I was part of the operations team, which was a really broad umbrella that was part of so there was the science team, which was called the operations team, and then the engineering team. As part of the operations team, I did everything from help select landing sites for what ended up being two rovers, Spirit and Opportunity, help design, calibration targets. My senior thesis was actually programming compression algorithms to be used by the cameras on board the rovers. We designed operation scenarios as to what was going to happen after we landed on Mars, contingency scenarios like if one of the solar panels fails, how do we make sure that we can fulfill the mission success criteria? So really it was quite broad, and I got exposure to various different parts of the mission as a result of the team that I was assigned to.
That's super cool. I mean, it must have been. Was it a learning curve when you jumped in? Was it like a bucket of cold water as far as how much work was involved, or were you prepared for that?
Oh no, I was not prepared at all.
Okay.
No, I wasn't prepared at all. It was a steep learning curve. I remember the first time I walked into the It was called the Mars Room on the fourth floor of the Space Sciences building at Cornell. It was this disorderly, windowless place lit by these dreary, like fluorescent lights. But I loved it. I spent the first few months just like listening to conversations, reading mountains of documents, trying to learn like a whole new set of acronyms that I knew nothing about. Really, the primary thing that I brought to the table was the coding skills that I had picked up in high school. I had taught myself how to code, and so those were really instrumental in getting me started. But in terms of the mechanics, I knew next to nothing. So it was a really, really steep learning curve.
Yeah, that's pretty wild. What would you say was your favorite part of that mission, the time that you spent there?
My favorite part was probably getting to work with Steve Squyres, who to this day is the best leader that I've ever had the pleasure of working with. Most people in his position, he does the opposite of, I think, what most leaders do. He is quick to take blame and for when something goes wrong, but also very quick to give credit to other people on the team. One of the first things that I think this was like maybe the second or the third week that I was working for him, I remember he had received this award. I don't know for what, but I remember distinctly him crossing out his name on the award and writing the names of the staff members that had worked on the mission for him and then giving the award to them, which I've never seen any leader do.
That's uncommon.
Yeah, very uncommon. And so getting to work with him and getting a glimpse of the way that he ran the mission, a lot of those lessons have stayed with me to this day. Just to give a few examples, like
sure.
In many of these missions, you've got scientists and engineers working together. And scientists tend to be more idealistic. They're trying to discover scientific truths, whereas engineers tend to be a lot more pragmatic, right? They have to grapple with like constraints about space and finances and budgets and deadlines and whatnot. And scientists tend to gloss over that from time to time.
Yeah.
And so on the bad missions, this marriage of scientists and engineers can quickly turn into a divorce. But on the mission that Steve led, the Mars Exploration Rover's mission, it was such a fruitful partnership. If you walked into any of these meetings that Steve would lead between scientists and engineers, you would be hard-pressed. If you just sat there for a few hours listening to everyone talk, you'd be hard-pressed to know which ones were the scientists and which ones were the engineers. The team was blended so well, with each set of team members so well versed in the other team's language that you couldn't tell which ones were the scientists and which ones were the engineers, which is really hard to do. And I think that's one of the reasons why the mission ended up being so successful, is that Steve was able to put together and lead this amazing team of really capable people.
And that's one of the great things. Thank you for sharing that first. Part of the thing that I hope to do with this segment with the people of science is help introduce people to people like you who had an experience that's not typical, because, or at least what's not typical to what people think scientists are. I think I remember reading it in your book about how people see scientists as people in a lab coat,
right.
And but that's so far from what the majority is. And your experience definitely shows that. Although I would say yours could definitely be unique. What's not unique is that you are in the illustrious club of basically aerospace engineers, rocket scientists that don't work in the field anymore.
Right.
I learned this as myself. I've put myself in this position here with this podcast, which is great. I think this is part of the side of science that I think I'm good at communicating, and this is more where I find myself. It's not really an engineer's position, but knowing that information helps a lot. So you mentioned about in the book that when you were working there, you at a certain point you figured out that science, or physics and basically what you were doing wasn't for you, for you anymore. What changed? Was this during the time when you were working on the mission?
It was, yeah. And I loved working on the mission. I didn't love the classes I took as much. I started to feel a strong disconnect between the theory that I studied in my physics and astronomy classes and the practicalities of the real world. I've always been more interested in these pragmatic applications. And I love learning about the sort of the thought process that went into to designing and operating a Mars mission, but I was much less interested in the substance of the math and physics classes I had to take. So I was like I think the best analogy might be like I was like a winemaker who loved making wine but didn't particularly care for the taste of wine. And there were classmates who were far better at the substance than I was. And so, I would have had to go get a PhD in astrophysics if I wanted to do really anything with that degree, and that just wasn't in the cards for me. So I ended up pivoting and going to law school, which is an unlikely change. And I always get questions about what happened that prompted the pivot, which I'm happy to talk about. But that was the reason why I ended up changing.
Yeah, I'm actually very interested, especially as someone that pivoted themselves. And if I had known more people had done this, I probably wouldn't have beat myself up about it for so long. And I'm sure that I know plenty of people who pivoted. And I think hearing about that early is really important. So yeah, if you could share that, that'd be great.
Sure. I ended up taking a college, I think this was my senior year, and it was taught by so the class was taught by a Cornell law professor, but he taught it only for undergrads. And I think it was called Nature, Functions, and Limits of the Law. And the way that he structured the class, it was just like a law school class. So he used the Socratic method, the question and answer method. We read real cases. And that class to me was like a breath of fresh air after all of the theory that I had been learning in my math and physics classes. And so I found myself far more drawn to the physics of society, and I decided to go to law school. And I took a year between college and law school and worked at a law firm just to make sure that was what I wanted to do. And it was, and I ended up going to law school because of that. But even after I changed trajectories, I brought with me this critical thinking toolkit that I had picked up from 4 years of astrophysics, and that's been so instrumental to me in so many different ways. I later became a law professor, and I see this with my students as well. Many people that end up in law school, they study political science or philosophy or literature, some sort of social science in undergrad, and then make their way to law school. But the best writers I worked with in law school, the best thinkers, the best students I've had, have by and large have had science and engineering backgrounds. That analytical way of thinking about the world actually ends up being really useful in law as well, which is one of the reasons why I wanted to write this book, Think Like a Rocket Scientist, because I've spent so much of my life taking these concepts and then applying them to areas that seemingly don't have anything to do with science, and I've firsthand discovered their utility, and I wanted to share that with other people as well.
No, it's amazing. I'm so glad that you wrote the book too, because I was going through it and I felt at home. I hope that feels like a compliment.
Oh, absolutely.
It was I kind of stumbled upon the mindset. Luckily I went to a school which was all engineers. I went to Worcester Polytechnic Institute. It was a amazing experience because everyone there was an engineer. So it was all mindset all the time. And it was across, you could have a biological engineer, you could have a chemical engineer, you could have a civil engineer, but everyone has that baseline thinking. And so I'm really interested to hear, especially in today's world, part of the drive that has me putting this stuff out there and talking about the scientific mindset is that I see it help myself in my day-to-day life. It helps traversing the chaotic on a day-to-day basis, and we have a lot of that today. So what is it about a rocket scientist's mindset in today's world? How does it help?
There's so many different ways, I think. So so the book is, I tried very intentionally to not make the book about the science behind rocket science. So I don't try to explain in any detail scientific concepts to the audience. It's more about the thought process, the frameworks of thinking, the ways of approaching complex problems that have utility far beyond rocket science. Because in the end, we all face complex problems in our lives, and those who can tackle those problems without clear guidelines and with the clock ticking enjoy an extraordinary advantage over other people. And that's what rocket scientists do. They dance with the unknown. They cope with the fear and the actuality of failure. So many of the issues that we encounter in our daily lives have already been mastered by this group of people. But because, as you said, Alex, and this is, I think, partially due to the science instruction, the way it's taught, there is such a disconnect between scientists and engineers and the rest of the audience that a lot of these ways of thinking haven't made their way over to mainstream audiences because they're really intimidating, right? Hence the saying, like, it's not rocket science, or it is rocket science. And so I wanted to write that book for that reason. I wanted to create an army of non-rocket scientists who approach everyday problems as a rocket scientist would.
No, I absolutely love that, and it's funny. I've been thinking about that a lot. It's like, what is it about science? Is it just the fact that the people that are working in science have kind of far and large stayed in science, and the mindset doesn't come out, or why do people, part of the reason why we started this segment is why do people think that science is out of the option for them? I think for a lot of people, they had a bad teacher or tests scared them. And so anything that reminds them of that, science being one of them, just turns them completely off. And that's what I loved about your book is you did stay away from, the hard technicalities of it. And I thought the way that you wrote it with the mindset was great.
Yeah, and I think that's spot on, Alex. So science instruction has to do with the disconnect, and I thought the other part of it might be, I just thought of this, the lack of cross-pollination as well. So scientists and engineers sort of work in their own world. There aren't many people who pivot like you and I did, and so some of those ideas from science, and some of my law classes, I give science examples, but there aren't many law professors who do that, and so that cross-pollination is lacking as well, which might be one of the other reasons for that feeling of separateness between science and engineering on the one hand and the rest of the world on the other.
Yeah, and one of the things I wanted to talk about from the scientific mindset here was the whole concept of known unknowns and unknown unknowns. Those are just a few of the scenarios that we deal with on the day-to-day chaos of what we kind of enjoy going through because it means we can solve a problem. So I wondered if you could just take a second to kind of break that down a little bit and how kind of it relates to the day-to-day world.
Sure, yeah. There's actually 4 different buckets. So there are known knowns. So those are things that we know that we know. There are known unknowns, and those are things that we know we don't know. So, for example, before the say the Challenger launch in 1986, we didn't know if the O-rings would function under 53 degrees Fahrenheit. Yeah. So that was a known unknown. There are unknown unknowns, which are things that we don't even know that we don't know. They're so inaccessible that we're not even aware of our lack of knowledge. And then one category, which I spent some time talking about, are unknown knowns, which is the land of self-delusion. So in that category, we think we know what we know, but we actually don't. So we assume we have a lock on the truth, but we're actually standing on this fragile platform. And I see that so much in society, particularly in politics, this idea of mastering the art of pretending to have an opinion, taking it until we make it. And that pretense of knowledge is, I think, so antithetical to how scientists operate, because that feeling of certainty, when you shouldn't be certain, blinds us to our own paralysis. It closes our ears, it shuts off incoming information from outside sources, and that can be a real source of problems. So I spent some time talking about in the book about what that means exactly and how to avoid it.
Yeah, and to go further on that, especially the political example, I got really into it when I was in college, really deep into it, and then got to a point where I was standing on that uneasy platform and decided I don't like this at all. And I think most people can relate to that. If you ever find yourself in a political argument, if someone says something and you start applying logic to that and there isn't an answer and there's a lot of kafas, a lot of like, oh, well, but this, usually that's the sign that someone is standing on that uneasy platform. And honestly, that's just exhausting to me. And it's why I stay away from it as much as I can. But that's very interesting.
Yeah, I agree. That's one of the many reasons why I cover so many different topics in not just the book, but in my popular writing as well on my blog. But I never ever write about politics.
Yeah. Could you share that with everybody if they'd like to follow?
Yeah, sure. Yeah. So my personal blog is at ozanvarol.com. So that's OZAN V as in Victor AROL.com, and I have an email newsletter that goes out every Thursday called The Weekly Contrarian, and you can sign up for that at that website. You can also go directly to weeklycontrarian.com.
Awesome, thank you. One of the other things we talk about on the show here is the idea of the balance. It's kind of, and I saw this throughout your book, especially the names of some of the chapters. They almost seem to contradict each other, but to me it made complete sense, and I can see why it may be confusing, especially to someone, especially in today's world where everything is so binary, ones and zeros. It's either completely this or completely that. You're either a Democrat or you're a Republican, or you're on the right side or you're on the bad side. It seems like there is no, it was contrary to everybody else, there is no stable state. In fact, that the stable state is a moving, fluctuating state, and people, I feel like, just don't know how to deal with that. And it's not a new problem. I mean, this has happened throughout history if you look back, but I'm interested in what you think about that.
Yeah, and I think there are probably two separate components to that. First of all, I'm glad you mentioned balance. With respect to the book itself, too, I hadn't thought about this before, but you're absolutely right. Like, the last two chapters in the book are called Nothing Fails Like Success and Nothing Succeeds Like Failure. And so there's definitely a balance element there. So two things. One is the idea of this, the world, people, objects, arguments as binary. You're either for something or you're against something. That, I think, dates back to our childhood. I mean, as children, we're taught to put things in two buckets, either good or bad. And ice cream is good, but strangers approaching you on the street are bad. And children don't expect anything bad from the good, and they also don't expect anything good from the bad. And so we put things into these two buckets, and that's how we make sense of the world. But over time, that efficient way of thinking about the world ends up becoming an impediment, because then we end up thinking about arguments and people in terms of black and white as well. So there is no gray zone in between, and that can be really dangerous for so many reasons. So I think that's one part of it. And the other part, which relates to the stable state you mentioned, I agree with you. I think stability in today's world is an illusion. Stability is companies, institutions that are moving and fluctuating tend to be much better able to weather storms than institutions that appear stable. The 2008 crash is a good example of this. The bedrock of the American economy, the housing market, crashed. All of these behemoth financial institutions sank. So it's easy to get complacent with where we are when we assume that we are stable, but complacency also makes you really vulnerable. So if you were a horse breeder in Detroit in the early 1900s, you would have assumed that your competition was other horse breeders breeding
Right.
faster and stronger horses, not car makers. Or if you ran a cab company 10 years ago, you would have assumed that your competition would come from another cab company, not Uber or Lyft.
Mhm.
And so the assumption that there is a stable state, I think, is a dangerous assumption. We are much more likely to progress and to fend off threats if we can get comfortable, if we dance with
Mm.
that moving, fluctuating state that the world is operating in.
Yeah, and the more I've learned, this podcast has been a great experience for me to give myself feedback, but also to receive feedback on what I'm doing well, what I'm not doing well. And what's made that, like, my quotes in quotes stable state is really when it's really more of just of a confidence thing. It's more of just am I confident enough to look at it objectively and say, am I not doing something correctly, and to not get too high on my own supply, if you will, um, I feel like it's not a skill that we all have, and I'm not great at it. I'm not trying to say that I've got it figured out or anything like that, but I can definitely say there's a correlation in when things have gotten better in my life. It's because I was looking at it from a scientific, more of a logical, not emotional mindset. And then everything just became, well, I can just change that and make an adjustment, instead of, this is over, I've messed it up. There's always a way
Yeah,
to get it to go the whatever way you need it to go.
absolutely.
Mm,
And what you said is really compelling. Science is built on the idea of falsification. Right?
mm,
So in modern society, we're wired to confirm what we think
mm,
we know, but scientists do the opposite. Their whole
mhm,
goal is to create falsifiable hypotheses, so hypotheses that can be proven wrong, and then try to prove themselves wrong. That's
mm,
the bedrock of science. And to be able to do that, of course, you have to get over the inherent confirmation bias that we all suffer from, which is to validate what we think we know, and step
mhm,
outside of your comfort zone by actually looking for things that prove what you think is right, but in
mm,
the opposite direction. So to be able to uncover evidence um, that proves yourself wrong, which is becoming increasingly harder to do because we're
for
all
sure.
operating in these echo chambers, boosted by all of the algorithms that social media platforms use, where we're only subjected to information that those social media platforms assume we're going to like.
Mm,
They assume that's going to resonate with us, and that makes it really hard for us to even see, let alone engage with the opposing view. And if we don't see it, we assume it doesn't exist. So it
right.
becomes all the more important to do what you're doing, which is to say, what am I doing wrong? How
Mm,
could I get better? What could I get better at? What am I change my mind about
mhm.
in the past year? And it's really important to ask those questions, because going back to the point about complacency, if you're not exposed to conflicting data points, it's just very easy to become complacent, even though you might be wrong.
Hmm. Yes, I totally agree. And one of the advantages of being on the outside, of knowing what it's like to work in the space industry, and just, well, I should say, what it's like to understand the science behind it. Um, I can, from the outside, kind of give a somewhat objective view. It's not
Mm.
perfect, but of the situation that's going on right now with the space industry. We have this whole new space race that's going on. And we're seeing a lot of innovation in the space industry, but there's definitely this binary thinking with NASA and say SpaceX, for instance, where there are people who are hardcores on both sides, and there are people within both companies, both organizations, I should say, that find themselves in a binary situation where they have their own echo chamber of what's right, what's good. Um, and they don't ever have a chance. And if there is someone that's in that organization that really has a different view of it, it's not very easy for them to share that, because they're kind of stuck in the fight. So I think it's important to kind of have these conversations, so at least they can hear them and other people can hear a different idea. So going with that, I'm interested to hear what you think. Well, first of all, I guess let's start on a good note here and then go on a productive route next. Why do you think that SpaceX is successful in today's space race?
I think a number of variables are involved. One is, and this is true for Blue Origin as well, but both companies were new to the industry. So they had the benefit of writing on a blank slate. Unlike NASA, they didn't have any like fixed internal ideas or processes, no legacy components. And so without the tug of their own past, they could let first principles drive rocket design, which is what they ended up doing. And I think this is one of the reasons why they were able to question many of the fundamental assumptions in the aerospace industry, like reusability, for example, that was just taken for granted that complete and quick reusability was a non-starter.
I can tell you, being a student at that time when they were doing it, there were professors that did not like it.
Yeah, I can imagine. Yeah, it just was, you look at the space shuttle and the attempt at making the space shuttle reusable failed because it was so expensive and so hard to do. And so if you're looking at that, if you're NASA and you have that institutional past, it's really hard to make an argument for reusability. But if you're new to the industry and you're writing on a blank slate, that argument becomes easier to persuade. So that I think is one part of it. And then again, relatedly, this idea of first principles thinking, which is their ability to question the assumptions in the rocket industry, I think have really helped SpaceX. Let's see. Other factors. It's never one thing.
No, it
vertical integration, I think, is really important for SpaceX. They're now relying on layers upon layers of contractors and subcontractors, which means they can go from idea to execution in rapid speed. That's unlike NASA. They've got a great team. I think SpaceX, true for Blue Origin as well, they were able to cherry pick the best engineers from traditional aerospace companies and make them work around the clock on these audacious projects, in part because of the vision they had. So Elon Musk, when he was hiring for SpaceX, his selling point was that the engineers would actually be able to do their job, which is to build a rocket rather than sitting in meetings or waiting for months for like a parts request to clear its way through the bureaucracy. So that I think is part of it. And finally, contrasting SpaceX to NASA, SpaceX is not beholden to politicians. NASA is. The budget is set by politicians in DC who don't have the same vision as the leaders of NASA do, and who have their own self-interests and their own ties to their own constituencies that may be at odds with the type of vision that a space agency might otherwise set. And because of that dependence on the inherent vagaries of politics, I think it becomes harder for NASA to do certain things compared to a purely private, not public company like SpaceX.
Would you agree with the statement that might be NASA's greatest weakness right now is the political aspect, or is there another weakness that you think they might need to look at?
I do think that's the primary weakness. And again, this isn't it's just the way that the agency is set up. It's a government agency, which means its budget is set by politicians in DC. So like Artemis, for example, is really exciting, but there are serious questions about whether NASA will get the required funding because you've got a lot of people in Washington who can say no. And I think that I do think is a primary weakness. And I should also mention, because I think NASA bashing has become really popular in some circles, NASA was the reason that I, like many others, fell in love with space exploration. I mean, for decades, the acronym NASA was the gold standard for innovation and creativity and critical thinking. And going back to your point about NASA versus SpaceX too, and this binary thinking, a lot of people who tend to side with private companies here and tend to trash NASA forget that if it weren't for NASA, SpaceX may not be around today. In December 2008, just 3 months after I think it was about 3 months after Falcon 1's first successful takeoff, NASA handed SpaceX a lifeline in the form of a $1.6 billion contract for resupply missions to the International Space Station. If it weren't for that, who knows where SpaceX would be now? But with that
100%.
said, yeah. So with that said, though, there's certainly the dependence on politicians is one weakness, and then the other one, which isn't as true today as it was, say, maybe a few years ago, but I think complacency certainly was part of it. We saw this with the space shuttle missions. I spent some time in the book talking about the Challenger and Columbia disasters. And in each case, I think complacency with repeated successful missions led to disasters that could have been and should have been avoided. And I do think that it was a mistake for us once we reached the moon to plant a flag and return home and send just humans to low Earth orbit for repeated trips to the International Space Station. I think for many people, after watching Apollo astronauts brave this, long journey, a 239,000-mile journey to the moon, it was quite boring, I think, to see astronauts fly just 240 miles up to the station. And so that, I think, was another weakness, although I think NASA might be overcoming that a little bit, maybe boosted by what private companies are doing around it.
Yeah, it is a really amazing opportunity that happened thanks to the administrator Charles Bolden that did that at the time with the Obama administration for the Commercial Crew Program, kind of invigorating those companies to hopefully have them as an option later. I mean, that to me was a huge divergent point in where we are today. And I appreciate you pointing out the NASA bashing and your love for it and the acknowledgement that, I mean, there's a reason why so many people are wearing NASA, specifically vintage NASA clothing right now.
Yeah.
It's partly the 50th anniversary, which is really what got everyone involved into space. And it ironically, it's what NASA used to mean to people. And I think they're hoping for this next phase. They're looking for that. I really do. You see that with everything. I mean, there's movies, there's TV shows, there's advertisements, everything is space related right now. And it is a great time. And what I hope from this, and we mentioned this earlier, is about looking at this hopefully objectively and logically. The reason I bring up the weakness is not so much to bash, but to point out where they can get better. Right. Because I think, like you said, echo chambers. Hopefully, if we talk about it enough times, then it gets to the right people who can make those decisions. Especially since, because it's a government agency, they really don't have the opportunity to come out and discuss these kind of things. So regardless, it's very interesting. The last thing I wanted to touch on was the idea of first principle thinking, first order thinking. I would really love, you laid it out in the book really well, and it was something I had heard Elon Musk talk about early on. But you've explained it really well. So I'd love for you to tell the folks at home what this is and why it's so important.
Sure. The credit for the term actually goes back to Aristotle, first principles thinking, who defined it as the first basis from which a thing is known. And basically, it's a way of taking a complex system and distilling it down to its fundamentals until you're left with just the raw components. So you hack through existing assumptions as if you're hacking through a jungle until you're left with those fundamental components. And as you said, the person who popularized this term, I think, is Elon Musk. And the famous example is when he first started thinking about sending rockets to Mars, sending people to Mars. He first was shopping on the American market and then the Russian market, and both turned out to be just outrageously expensive. As rich as Musk was, it was just too expensive for him to buy rockets and send payloads using rockets that other people had built. And he realized, though, and this was, I think, during an airplane trip, one of his shopping sprees in Russia, where he's returning home empty-handed, he has this epiphany, and he realizes that his thinking had been flawed. He hadn't been using first principles thinking. He'd been using what he calls reasoning by analogy, which is looking at what other people have been doing. In this case, it would have been buying rockets that other people had built. He asked himself on this airplane ride, what is a rocket made of? Like, if you go back to first principles, what are the smallest subcomponents, the fundamental non-negotiable raw materials? And he came up with some aerospace-grade aluminum alloys, some titanium, copper, carbon fiber. And then he asked himself, well, what's the value of those materials on the commodity market? And it turns out that the materials cost was like 2% of the typical price of a rocket, which is a crazy ratio.
It's wild.
And so he just said, okay, well, I'll cut my own metal instead of buying rockets that other people had built. And so that's an example from the rocket world, but there are many other examples of other companies using first principles thinking to upend their industries. So just to give a few examples, we used to think that physical stores and late fees were necessary for video rentals, but Netflix questioned those assumptions and gave us streaming. We used to assume that venture capital funding and bank loans were necessary to be able to start a new business or launch a new product. Questioning those assumptions gave us Kickstarter and Indiegogo. We used to assume that restaurants required an immobile kitchen and a brick and mortar location and tables and what tablecloths. Questioning those assumptions gave us food carts. And so there's various different examples of. It's really hard to do, by the way, because we're often shackled by our own past of the assumptions that we're operating under, and it's really hard to zoom out and to see those assumptions and to apply first principles thinking. But the people and companies who've been able to successfully do that have excelled as a result of it.
I'm so glad that you said the part that it's hard, because I've used this without even realizing it. I did it in how I wanted to live my life. I just wanted to enter my love of science and enter the space industry in some way and make some kind of an influence in it. And I did that through first order principle thinking, and I just saying, okay, this is what I want to do. How do I structure my life around that so that I can get there? And it's I have failed a lot of times trying to do that over the past 5 years. And I'm only kind of at a place where, I've gone through enough revisions and I've seen enough examples where, okay, this doesn't work. This doesn't work. All right, let's adjust it for this scenario. This year is a big year where I'm adding some more structure to what I'm doing, to allow myself to be happier when I do this and to really, really enjoy this, but to also get it done in the way that it needs to get done. And I'm so glad that you mentioned it is hard, because I think we only really talk about it when they're successful. Like Netflix, we already know Netflix.
Sure.
SpaceX is already successful. And I think I've done it where we almost assume it's like, oh, they just are so smart, they just see it. And it's like, no, they failed enough times at it and found the right one.
Absolutely. Yeah, we're seeing glass tends to reflect more than it reveals. And so when we're looking at these final products, and none of these companies are final, of course, but at least in their current states, it's hard to see, or it's hard to remember, I should say, the mistakes and the failures. And I mentioned with respect to SpaceX, SpaceX was on the verge of failing. Becoming a rich guy just goes bankrupt.
Another millionaire that threw all his money away. Yeah,
exactly. Just playing with toys and failing miserably, which is what the first 3 Falcon 1 launches were.
Really bad, yeah.
but they learned from each mistake. Each failure revealed important lessons. And on the 4th try, Falcon 1, launched off the launch pad and into the record books. But yeah, you're absolutely right, though. We don't see those mistakes, those struggles, those failures, if you're just looking at the success stories as they stand today. But one thing that I've learned doing the research for this book and interviewing many people outside of the aerospace industry about their failures is that everyone around us has gotten to where they are by failing, and failing some more. And it's not just failing, by the way. It's actually learning from their failures as well.
Yes.
There's this mantra which I criticize in the book from Silicon Valley about failing fast. And that's important, but even more important is to learn fast, because just because you're failing doesn't mean that you're actually learning from it. There's so many examples of this. As I said, a number of research studies in the book, but when entrepreneurs fail, it doesn't necessarily mean that they've actually gotten any lessons from that failure, because when they do fail, they tend to attribute what happened to other factors, to other people, as opposed to what they did wrong. But the companies who can not only return to first principles, but also operate in a way where they're failing and also learning from those failures and improving as a result, those are the institutions and companies that tend to stand the test of time.
Ozan, you said it perfectly. Thank you. So let's close out here. Thank you for joining me, first of all. I really appreciate you joining the show.
My pleasure. Thank you so much for having me, Alex.
Of course. Let's tell the folks, when will the book be out? It'll probably air after it comes out, but just in case, the book should be out. What date?
April 14th.
April 14th.
And it's available everywhere that books are sold. If you want an easy way to access all of the links to buy the book, you can head over to rocketsciencebook.com. And you will find the book there, or otherwise you can just head over to Amazon, Barnes & Noble, or your favorite indie bookstore and find the book there as well.
Perfect. Ozan Varol, thank you so much for being on the show today. Another example of people in science. There's plenty of us out there, and we all come from various backgrounds. Ozan, again, thank you for being on.
Thank you, Alex. It was my pleasure.
Stay safe, everybody. Spread love and spread science. We'll see you next time on Today in Space.